wabarakatuh, and a very good morning I bid to everyone. So my name is Muhammad Rasydan bin Abdul Rashid. Um, so today I would like to present to you assignment 3, which is electronic 1 ELE232. Okay, that is that. So from the assignment 3, we have to answer this question. Okay, as you can see in this question, this is DC analysis FET N channel D MOSFET. Okay, why is it called N channel? Because the flow of the current in the circuit is from drain to source. Okay, so that's why it is called N channel. Okay, as you can see in the question given, from the first Roman and the fourth Roman. So first is to find the drain current IDQ. Second is DC gate source voltage VGSQ. Third is gate source voltage DCQ. And the fourth is terminal voltage VS and VD. Okay, let us start. So how to answer the question? Okay, there is a few steps for us to follow for us to able to answer the question. Okay, step 1 is construct transfer curve table. Okay, later I will show you how to draw. Okay, second step is draw the transfer curve. Okay, after you constructing the table, you have to draw the curve. Okay, step 3 is to find the KVL from the constructed circuit that consists VGS and ID. Step 4 is construct linear graph based on KVL in step 3. Step 5 is draw the linear graph. And the last one, step 6, is find the intersection between the curve and linear graph to determine value of IDQ and VGS so that we can get the other value from that. Okay, so step 1. So step 1 is required us to find the value of ID. Okay, how to find the value of ID? So we can find the value of ID by applying this formula, which is ID is equal to IDSS times with 1 minus VGS over VP squared. Okay, so as you can see, the value of IDSS have been already given in the question, which is 6 milliampere, this one. Okay, the value of VP as well has been given in the question, which is negative 3 volt. Okay, so from by following value given and the formula, we substituting all the value into the question, into the formula to gain the ID. Okay, for the VGS, we require to input the following value from 0 to negative 3. Okay, why it is negative 3? Because it is stated that the VP, which is the peak voltage, is negative 3, which is the limit of the VGS is negative 3. So we have to input the VGS value by the following value lah, from the 0 to the negative 3. Okay, after been substituting all the value from the 0 until the negative 3, we get the value of 6 milliampere, 2.67, 0.67, and 0. Okay, after get the value, we construct the table. Okay, the function of the table is to easy for us to construct the graph. Okay, next step. Okay, after getting all the information in the table, we constructing the graph. Okay, which is ID, which is milliampere, over the VGS. Okay, so from the following value, we get the transfer curve graph, which is this one, the curve one. Okay, so after you transfer all the after you plotting all the graph, you get the curve graph. Okay, so next step is find the value of VGS from KVL in the circuit. Okay, so as you can see here, this is the circuit from the question given. Okay, the circle, the red circle that I already put in this slide shown that we have to applying the Thevenin theorem in this circuit to simplify the circuit to become this kind of circuit, so that it easy for us to to applying the KVL to calculate some value that we want in this circuit. Okay, so first step is to convert all to convert the circuit to to become the simply one. Okay, so we have to do the Thevenin theorem. So as you can see here, RTH is 110 mega parallel with 10 mega. So that we got the value of 9.167 mega ohm. Sorry. And for the VTH is R2 over R1 plus R2, which is 10 mega over 10 mega plus 110 mega times with for source voltage source, which is 20 volt, and we get the value of 1.67 volt. Okay, after getting all this kind of value, we convert circuit. Okay, before that, before I before I forgot. Okay, as we know, in the DC circuit, all the value of capacitor, all the capacitor will be open circuited. So then, as you can see here, I already cancel out all the capacitor, because as you know, when the capacitor become open circuit, so the line toward the capacitor will be diminished because of the open circuit. So all the capacitor in the circuit will be cancelled out. So therefore become this kind of circuit. Okay. Okay. So this is the VTH. This is the RTH. This is the RS, RD, and the voltage source. Okay. So second Roman question is asking us to find the VGS value. So where is the VGS value? VGS value is here. Okay. Between the G terminal and the S terminal. So VGS is okay here. Okay, so to find the value of VGS, we have to apply the KVL in this loop. Okay, starting. Okay, you can start from the VTH or you can start from the 750. Is it's up to you. Okay, for this example, I will start from the VTH. Okay, so VTH, as you can see here, I'm starting from the VTH value. So negative 1.67, okay, plus RTH, which is 9.167 mega, time with IG, okay, plus VGS, VGS is here, plus with 750 IS, okay, IS is here, okay, equal to 0. Okay, as you know, the value of IG is actually 0 ampere, and the ID is equal to the IS. So to easy for us to calculate the value of the VGS later on, we cancel out the IG, because as we know it is 0. Okay, and the value of IS we substituting with the value of ID. Okay, so therefore we get the VGS is equal to 1.67 minus 750 ohm divided by times with ID. Okay, so this is the formula. Okay, next step. So from the formula that get from previous step, which is VGS is equal to 1.67 minus 750 times with ID. We constructing the table. Okay, and we substituting all the value of ID with 0 to 6 milliampere. Okay, why it is 6 until 6 ampere? Because our previous graph is limit at the 6 ampere, so we plotting the 0 until 6. Okay, you actually can take just 3 point from this, but in this example, I'll plotted I'll find all the value from the 0 until the 6. Okay, but if you want to um, to take just three, okay, it's okay, but the limit is three. If two, it is not preferable. Okay, so all the value of ID will be substituted into the formula to find the VGS value. Okay, so we get the, okay, for the 0 milliampere we get the 1.67 volt. Okay, for the 1 milliampere we get the 0.92 volt, and the 2 milliampere we get the 0.17, and so on until for the 6 milliampere, which is negative 2.83 volt. Okay, after you done filling up this table, you are required to construct, to plot all the value into the previous graph. Okay, that you are already done the curve transfers. Okay, so you first you plotted all the value into the graph. Okay, and then you um, draw the line. Okay, draw the line. Okay, so you get this kind of the circle. Okay, so it is linear graph. Okay, next. Okay, next we get this kind of okay, so from transfer curve and linear graph we obtain the intersection point here. So from this we obtain the actual value of VGS and ID. Okay, so we just get the intersection point and we get the VGS, which is negative 0.75 volt, and for the IDQ we get the 3.3 milliampere. Okay, so from the intersection point we get the actual value for the both value lah, for the VGS and IDQ. Okay, so next step, so hence we already get the value of VGS and ID, okay, from the graph. Okay, next, the question asks us to find the VDS value. Okay, where is the VDS? Okay, as you can see here, the VDS is actually between the terminal drain and the terminal source here. Okay, I already draw the polarity. Okay, so before we undergo the next step, which is KVL, I would like to remind you to clarify all the polarity of the component first in this circuit for us to prevent all the mistakes that we done in the KVL. Okay, so you settle up the polarity first, and then you do the KVL. Okay, so actually there is two kind of step that we can use to find the VDS. Okay, first step is we just do the KVL in this loop to find the VDS. Okay, that's first, and the second is we find the VDS from the VD minus VS. Okay, so we are running this step first. Okay. Okay, so we do the KVL. Okay, actually you can do, it's up to you to start from the negative 20 or negative 750. It's up to you. Okay, the answer will be same. Okay, so we do the KVL in this loop. So we get negative 20 plus 1.8K ID plus VDS, this kind of VDS, plus 750 IS. Okay, so as I said earlier, the value, it is preferable for us to substituting the IS into the ID. So that is the first method. Okay. So the second method is to it's VDS minus VD minus VS. Okay. So we have to that the VD first. Okay. So in this question, number 4, the question requires us to find the VD value and the VS value. So what we do is we create the line of VD here. Same goes to the VS. Okay, the tips to draw the line of VD is you do in the near the terminal, each terminal. Okay, for the ID is here and the IS is here. Okay, so after you draw the line here, VD, and here is Vs, you can do the KVL loop here. Okay, in this loop. So for the VD, okay, so here negative 20 plus 1.KID plus VD. Okay. Again, I remember you to done all the polarity first before you do the KVL. Okay. So you get 20 minus 1.8 KID. So you just substituting the value of ID and you get the 14.06 volt. Okay. For the VS, same as well. You do the KVL here and you get negative Vs plus 750 Is, and we change the Is to the ID. So you got Vs is equal to 750 ID, and you just substituting the value of ID, which is 3.3 milli, and you got the 2.48 volt. Okay. So if you want to try this second method for find the VDS, you just take the value from VD and the VS. So VDS is VD minus VS. So 14.06 minus 2.48, you got the 11.58 volt, which is nearly same with the another method. Okay, so here we done all the question. Okay, from thank you.